This is the continuation of the model 2, that is Bernoulli's equation for the real fluid. Okay, Bernoulli's equation is assumed to be for ideal fluids, that is fluids with no viscosity. But in case of real fluids, viscosity will be there, so the losses due to friction take place, and these losses have to be taken into consideration. Bernoulli's equation between 2 points for the real fluid is P1 upon rho into G plus V1 square upon 2G plus Z1 is equal to P2 upon rho into G plus V2 square upon 2G plus Z2 plus HL head loss due to friction. The HL is equal to loss of energy between the points 1 and 2. Okay. Therefore, simple problem to understand this. A pipe of diameter 30 cm carries a water at the velocity of 20 meters per second. Therefore, the pressure at the point A and B are given as 34.335 Newton per centimeter and 29.43 Newton per centimeter square respectively. While the datum head at A is A and B are 25 meters and 28 meters, find the loss of head between A and B. So ZA is at lower and ZB is at here. Okay. So at a point A, diameter D is equal to 30 into 10 raised to minus 2 meters. V is 20 meters per second. Then PA is equal to 34.335 into 10 raised to 6 Newton per square meters. And P pressure at B equal to 29.43 into 10 raised to 8 Newton per square meters. ZA is equal to 25 meters and ZB is equal to 28 meters. We know the total energy at A equal to EA is equal to P1 upon rho into G plus V1 square upon 2G plus ZA, that is equal to 34.335 into 10 raised to 4 divided by 9.81 into 1000 plus 20 square into 2 into 9.81 plus 25. Therefore, total energy at B equal to EB, PB into rho into G plus V2 square upon 2G plus ZB, that is equal to 29.43 into 10 raised to 4 divided by 1000 into 9.81 plus 20 square into 2 into 9.81 plus 28. Okay. Therefore, EA minus EB equal to 2 meters. Okay. So similarly, next formula, the problem, a pipeline carries an oil of specific gravity 0.8, change in diameter from 300 mm to at a position of a 500 mm diameter at a position B, which is 5 meters at the higher level. If the pressure at A and B are 19.62 Newton per centimeter square and 14.91 Newton per centimeter square respectively, and the discharge is 150 liters per second, determine the loss of head and direction of the flow. So Q is equal to 150 liters per second, S is equal to 0.8. Okay. Therefore, at this section A and this is section B. Okay. So diameter is here and diameter is here. So section A is equal to EA P upon rho into G plus V square upon 2G plus Z1 is equal to 19.6 into 10 raised to 4 divided by 1000 and 0.8 into 9.81 plus 2 into 9.81 plus 0, that is equal to V1 into A1 is equal to Q. Therefore, V1 is equal to 50 into 10 raised to minus 10 divided by 5 into 3000 into 10 raised to minus 10 divided by 4. Then EB is equal to 14.91 into 10 raised to 4 divided by 1000 into 0.8 into 9.81 plus, okay, divided by 1 divided by 2 into 9.81 plus the 4. So EA minus EB is equal to 1.45 meter. Since EA is more than EB, the flow is taking place from A to B. Okay. Then third problem, a conical tube of length 2 meters is fixed vertically with its smaller uh, end upward. The velocity of flow at the smaller end is 5 meters per second, while at the lower end it is 2 meters per second. The pressure at the smaller end is 2.5 meters of liquid The loss of head in the table is 0.3 into v1 minus v2 the whole square over 2g, where v1 is the velocity at the smaller end and v2 at the lower end respectively. Determine the pressure head at the lower end. Flow takes place in the downward direction. So length is 2 meters, v1 is equal to 5 meters, then v2 is equal to meters per second, or p1 upon 20 is 2.5 meters. HL is equal to 0.35 into 5 minus 2 the whole square, that is divided by 29.1, that is equal to 0.16 meters. P2 upon 20 is equal to that is Bernard's equation. P1 upon 20 plus P1 square upon 2 g plus Z1 is equal to P2 upon 20 plus V2 square upon 2g plus Z plus HL. Z2 is equal to 0 and Z1 is equal to meters. Therefore, P2 upon 20 is equal to 5.47 meters of the fluid. Next one, the momentum equation. So we know that impulse momentum equation states that the impulse of the force F acting on a fluid of mass m in a short interval of the time dt is equal to the change of momentum, that is dou nt mv, in the direction of the force. Force exerted by the fluid on a pipe bend is equal to P1 into A1, that is equal to, here we can see that we can result into horizontal and vertical component V2 into sin theta, V2 into cos theta. So P2 into E2 into cos theta, P2 into E2 into sin theta. Okay. Therefore, the impulse momentum equation can be used to determine the resultant force exerted by the flowing fluid on the piping bend. So consider two sections in the pipe, that is V1 is the velocity of flow at section 1 and P1 is the pressure intensity at the section 1 and A1 is the area of cross section at section 1. V2, similarly V2, P2 and U2 are the corresponding velocities of pipe at this section 2. Let Fx and Fy be the component of the force exerted by the flowing fluid on the bend in x and y direction respectively. The force exerted by the pipe on the bend on the flowing fluid is minus Fx minus Fy. Therefore, the other external force acting on the fluids are P21 and P22 at section 1 and section 2 respectively. The momentum equation in x direction is equal to net force acting on the fluid in the x direction is equal to rate of change of momentum in the x direction. So that is given by P1 into E1 minus P2 into eta into cos theta minus Fx is equal to mass per unit, mass per second rate of change of velocity. Similarly, P1 into E1 minus P2 into eta into cos theta is equal to minus Fx, that is rho into q is equal to final velocity minus initial velocity, that is equal to rho is equal to mass divided by volume. Therefore, P1 into E1 minus P2 into eta into cos theta minus Fx is equal to rho into q into P2 into cos theta minus of E1. Therefore, Fx is equal to P1 into E1 minus P2 into E2 into cos theta minus rho into Q into V2 into cos theta minus of V1. Therefore, momentum equation in the direction phi is equal to net force acting on the fluid in the y direction is equal to rate of change of momentum in y direction. So that is equal to minus P2 into E2 into sin theta minus Fi into rho into Q into V2 into sin theta minus Q. Therefore, Fi equal to rho into Q minus V2 into sin theta minus V2 into E2 into sin theta. Therefore, resultant force is equal to root of Fx square plus Fy square. Therefore, the angle made by the resultant force with the horizontal is theta is equal to tan inverse of Fy divided by Fx. Okay. A 45 a 45-degree bend connected in a pipe line. The diameter at the inlet and outlet of the bend being 600 mm and 300 mm respectively. Find the force exerted by the water on the bend of intensity of pressure at inlet to the bend is 88.2 kPa and rate of flow of water is 600 liters per second. So given theta is equal to 45 degree, d1 is equal to 600 10 to minus 3 meters, That is equal to 3 into 10 raised to minus 3 meters. P1 is equal to 88.29 into 10 raised to 3 Newton per square meters, and Q is equal to 610 raised to minus 3 meters cube per second. So this is the pipe which is bent at this, and this is the here is the P1 value and P2 value, and this is the D1 and D2 value. Okay. So here is equal to pi d square by 4, that is equal to pi into 600 into 10 raised to minus 3 divided by 4 into the whole square, that is equal to 0.2827 square meters. 8 is equal to pi by 4 into 3 into 10 raised to minus 3 the whole square, that is equal to 0.07068 square meters. Therefore Q equal to A1 into V1, therefore Q equal to A2 into V2. So that is equal to 8.48 meters per second, and V1 is equal to 610 raised to minus 10 divided by 0.2827, that is V1 is equal to 2.122 meters per second. Then applying the Bernoulli's equation, P1 upon 1 plus V1 square upon 2 plus Z1 is equal to P2 upon 1 plus V2 square upon 2 plus Z2. Here Z1 is equal to Z2. Therefore, P2 is equal to 54.5 into 10 raised to minus 10 Newton per square meters. Therefore, Fx is equal to how much? Therefore, that is P1 into A1 minus P2 into cos theta minus Fx is equal to rho into Q V2 into cos theta minus f1. Therefore, Fx is equal to 19911.4 Newton. And therefore, minus P2 into A2 into cos theta is equal to minus Fi is equal to rho into Q1 V2 into sin theta minus 0. Therefore, Fi is equal to minus 6322.2 Newton. R is equal to root of Fx square plus Fi the whole square, that is equal to 20891 Newton. Theta is equal to tan inverse Fx minus Fi. Fx divided by Fi summation Fy divided by Fx, that is tan inverse 6322.2 divided by 19911.4, that is equal to 17 degree with the horizontal. Okay, next I will continue the next problem. Okay, thank you.